For this video, I'm going to go over some graphs that you should know about and have familiarity with, just to kind of help you out, things that come up often in a calculus class, right? So there's some graphs you should be familiar with. I would say linear graphs you should be pretty comfortable with. You should be comfortable being able to identify like y-intercepts, what the slope is, calculating slope from a graph, right? Any of those things with linear you should feel comfortable with. For quadratic, right? And this is something in that ax squared plus bx plus c form. You should feel comfortable knowing what the y-intercept is, right? Which is the c value. If it opens up or down, that has to do with the a value being positive or negative, right? And what are the x-intercepts? And so that has to do with when y equals 0. And so you should feel pretty comfortable with any given quadratic in terms of that information. Other polynomials like basic end behavior, general shape. So if I tell you a cubic, you have an idea what that means, stuff like that. And then some non-polynomials, especially exponential growth and decay graphs. We're going to look at a particular one, but stuff like y equals a times b to the x, where growth is when, it's helpful if I spell, growth is when b is greater than 1, decay when b is less than 1, and then the natural log graph. Okay, so we're going to take a look at some graphs that are especially important, kind of a little bit more in depth. Okay, and the first one that we're going to talk about is this graph. Okay, hopefully you recognize this as an exponential growth, and specifically this is the graph of y equals e to the x. It's a graph that comes up a ton, and so that's going to be important, and I want you to know some key attributes of this graph, right? One major thing I notice is on the left-hand side of this graph, you should see or be able to identify a horizontal asymptote. Okay, so we have a horizontal asymptote. On the left of the graph. And if I wanted to describe what that horizontal asymptote is, right, I would give it an equation, and it is the equation y equals 0, okay, because that's a horizontal line. If I take a look at domain, so it's kind of connecting to that previous video, right, are there any issues like holes or vertical asymptotes? Nope, right, so the domain, I can put in any x value I want to this function and come out with a y value. What about the range? Okay, as you look, are there restrictions on the range? Yeah, right? There are no negative values at all. It never dips below the x-axis, and so the range is that actually y is greater than 0. Okay, so that means that this, any outputs you get, this is always positive. And that's something that's going to come up later on in class, right? In terms of x-intercepts, there aren't any, right? So it never actually touches the x-axis, and so there aren't any x-intercepts. And in terms of y-intercepts happen when x equals 0, right? And so if I put in x equals 0 to the function, I get e to the 0, which is equal to 1, right? And so y-intercept at 1. So if I look up here, right there, that is the order pair 0, 1. Okay, I would say those are the key attributes that you should be super familiar with for this graph. Okay, now the next graph that I gave you here looks similar, right, but it's kind of flipped around. And so this is actually the graph of y equals e to the negative x, which we'll talk a little bit more about negative exponents, but is the same thing as 1 over e to the x, right? These two things are interchangeable. All right, so let's talk about some key attributes. This also has a horizontal asymptote. But this time, instead of being on the left, it's on the right. It still would be, if I wanted to give it an equation, right, it still would be y equals 0, that horizontal line. Okay, let's talk domain. If I think about all the x values, no restrictions, no vertical asymptotes, anything like that, so all real numbers. Okay, How about for the range? If you take a look, right? Same as the other one, y has to be greater than 0. Again, we're talking about a graph that is always positive in terms of the outputs, which kind of makes sense because if the graph on the left was always positive, if I do 1 divided by a positive number, I'm still going to get positive outputs, so that's why that didn't change at all. Okay. In terms of x-intercepts, still none, right, because of that asymptote. And then for the y-intercepts, same thing, right? The y-intercept is 1. Same reason. If I do 1 over e to the 0 power, I get 1 over 1, which is 1. Okay. Or I could even do y equals e to the negative 0. Well, e to the negative 0 is the same thing as e to the 0, which is 1. Okay. So up on this graph, again, it's crossing the y-axis at the order pair 0, 1. And so those are two graphs that you should be pretty familiar with because they do pop up a fair amount as you go on in calculus. Okay, and they also relate to the next thing, so we're going to talk about that right now. Okay, so let's look at a familiar graph and use some other info we know to develop another well-known graph. My hope is after that previous slide you recognize that this right here is the graph of y equals e to the x. We just had a conversation about that. And the idea here that we're going to be talking about is we know that inverses undo each other. Okay, and so we want to think about what undoes e to the power of something, and that's the natural logarithm, aka ln. Right, and so we also know that inverses are reflections over the graph of y equals x. And so that's why I included this line on this particular graph. And so what we are going to do is reflect the graph we know, stuff about y equals e to the x over the line y equals x, to come up with the graph of what natural log x looks like. Okay, when you reflect around this line, what you're saying is you're basically interchanging or swapping the x's and y's. So if I take a look at this horizontal asymptote, this part, right, is going to become a vertical asymptote in this reflection. So if I reflect it over, this part right here basically becomes a vertical asymptote. If I look at important points like this point right here, right, on the e to the x graph, 0, 1, when I reflect it or flip-flop places, that's going to become 1, 0. So this is going to come up, it's going to come up and go through that. So this is now an x-intercept for my graph. And then I just need it to kind of mirror, and so it's going to be something kind of like this. And so this graph that I've drawn in teal, this is the natural log of x graph. Okay, so you can see the reflection, how if you fold on that line, right, y equals x, if you fold on this line, these two graphs would meet up. That's because they are inverses of each other. If you really understand this graph, then you can always kind of come up with the key characteristics of the natural log graph, but my hope is that you actually feel pretty comfortable with some of those. So let's kind of just summarize that. So here I left off the e to the x stuff, and we are just taking a look at y equals natural log x graph. Okay, and what are some key attributes? Well, now there's not a horizontal asymptote, right? Now there's a vertical asymptote. And that vertical asymptote has an equation of x equals 0, right? It's a vertical line when x equals 0. Okay, and now let's talk about domain. Okay, are there x values that I can't put into this function? Yeah, definitely there are now. Right now, it's that x has to be greater than 0, right? There is no graph over here on this side, right? It can't go over there, it can't cross over that vertical asymptote. Also notice that this is the same as the range was, and so they have kind of flip-flop domain and range. Speaking of range, right? Before my domain was all real numbers, now my range is all real numbers because I can get any y value I want from starting at very little, right, and getting up to very, very large. I can still get any y value I want. So they did flip-flop from what they were in that e to the x graph. Okay, here, okay, now there's no y-intercept, right? It never actually touches the y-axis. And here my x-intercept, we talked about this, right? It's 1. and that's from solving the equation 0 equals ln x. Okay, if you take e to the both sides here, you get e to the 0 equals x, which means 1 equals x. Okay, and that's exactly what we talked about on that previous slide, that the y-intercept for e to the x became the x-intercept for natural log x. All right, so mentally you should be able to think of this graph and think through these key attributes for any of the graphs that we talked about today. The list we originally started with here, e to the x, e to the negative x, and finally natural log x.